So, Gene, great to see you. Great presentation. So, I guess with this news of the financing, you don't need the 100,000 anymore. You're good, right? We're all good.
Well, you're going to put that in there.
There you go. There you go. So, tell me, what are the barriers to entry to getting into this market? Obviously, it's a great idea. You know, anything. Anything that you can accelerate by. It looks like 10, 20x is the time frames we're talking about. If I did my math correctly, is great. What do you guys know that nobody else knows about acceleration and moving a GPU? Why can't the people that do this already go figure this out?
Okay, so that's a very good question. The competitive advantage that we have is 3 technologies that are necessary to make this work. The first one is atmospheric science and meteorology. We have people who are the experts in that field and been doing this for years and years and years for the US government. Secondly, you need to have the high-performance computing, which is the CUDA language understanding. And then third, you need to understand weather models. And those 3 combinations are very, very difficult to find. That's what gives us the competitive advantage.
And you don't think that, you know, if you guys nailed it, that the National Weather Service, the European model, these guys would say, oh, these guys are using GPUs, we got to like move to that construct. You don't think they do that?
Okay, that's the national or the European model is a global model. And they're very, very good because they have outstanding modeling capability. But again, it's a global model. And we're a regional model. The other thing is that this is a disruptive technology, highly disruptive technology. The US government typically doesn't employ disruptive technologies early. They're in about status quo and keeping everything very maintained. Plus the fact they just spent $45 million on a computing system that doesn't include GPU.
How do we fix that?
How will I fix what?
The fact that they spent $45 billion on a computing system that doesn't actually work.
That's your government for you.
Good answer. So moving on, how would the service benefit, say, a network television service like, say, NBC?
All right, this is...
Funny you should ask that.
Yeah. The thing is, they get their data from special companies that really sell for TV broadcast. We're focused on the high-level commercial users who are really dependent on weather, knowing it now, so that they can make decisions that are going to save them money and save them liability. Not that TV broadcasting isn't important, but they get that weather that they need. Now, eventually, our forecast could get to them, and it would improve their weather so that you know whether it's going to rain or not going to rain. But our customers are more the oil and gas or the aviation who's concerned about landing on at an airport. For example, if you're dealing with utility companies, they've got to make sure they have staff in place in case the weather is so severe that if they don't have the staff, then they go off to spot buy power.
Well, it looks like yours is accurate enough that you could actually anticipate spot outages.
That's the idea.
Right.
Yeah, pretty great stuff.
Thank you, gentlemen.
Thanks.